The rectangle is the next object we're going to look at. It's defined by xy coordinates which specify the top left corner of our rectangle, and then height and width, which will tell how wide and how high the rectangle are from the initial coordinates that we give it. And then there's also an arc height. This arc height is used to represent the roundness of the corners on our rectangle. These parameters effectively represent the diameter of a circle tucked away in the corner. Note that the arc width and the arc height can be independent. So that means that it doesn't have to be, strictly speaking, a circle that's tucked in these corners, but it could be more like an ellipse in a sense. If we take the simple case of thinking of it as a circle for now, then in that case the arc height and the arc width would be equal, and they would both represent the diameter of the circle. Therefore the radius of the circle would then be half of that. So if you look on this diagram, you see arc height divided by 2, arc width divided by 2, and again, if those were the same, this would represent the radius of a circle that's tucked in the corner. That means the round part stops at a distance AW/2 from the corner and AH/2 from the corner. Now that captures the principle of how this rounding of the corner works. The only thing we have left to discuss is what happens if AW and AH are independent and they are at the same value. Well, it simply means that the roundness could go further before it approaches the top if AW is greater than AH, and or vice versa if AW is smaller than AH. So again, those things don't need to necessarily match. When they both are set to 0, or that would be their default values, effectively you have a circle of diameter 0, which means you have a very, very sharp corner. That would represent just a 90-degree corner on your rectangle. In the UML diagram that you see here, it's noteworthy that the rectangle only has two constructors, one which creates an empty rectangle and the other in which you can specify the x and y coordinates and the width and height of your rectangle, but the only way you can specify the arc height and arc width is to use the setters that come with those data members. We're going to demonstrate the rectangle now, and your author, I think, had a great deal of fun putting together some of these demos because some of them are rather interesting and fun to play with. In this particular case, what he's done for us is he's taken a rectangle and rotated it into a number of different positions and overlaid it on top of itself, giving an interesting effect, as well as something a little bit more boring, which is just to show three rectangles on the left side of the window, as we're going to see. So let's get all the usual stuff out of the way. We have a bunch of imports up at the top as usual. We extend application to do this job, and we override the start method. And then somewhere down at the bottom here, we're going to drop our scene that we finally produce up above into our border pane rather, into a scene. We're going to set the title on our primary stage, drop the scene into the stage, and show the stage, and that's the usual stuff. So the stuff specific to this demo is actually the part that you see right here in blue. So let's go ahead now and peck that apart line by line. Well, the first thing we do is we create a rectangle called R1 right here, and we give it parameters that you see here. So in other words, its top left corner is going to be at location 2510, and its width is going to be 60, and its height is going to be 30. We set its stroke color, that is the outline of our rectangle, to black, but we set the fill color, the interior part of our rectangle, to white in this line. We then go on to create two additional rectangles, R2 and R3, at locations 2550 and 2590 respectively. So notice the 25 here and here and here. So all three of these rectangles are going to line up where we put them in our scene on the left hand side, but they're going to have different vertical coordinates. This one's going to be at the top because it starts at 10, and remember, as the y values increase, you go down towards the bottom of your window. So this is actually 40 pixels lower, and this is another 40 pixels lower. So we're going to have not 40 between them, but a distance from edge to corresponding edge of 40 vertically as we go down. Apart from that, the rectangles are the same. In other words, they have different starting positions, but they all have the same dimensions. They're all 60 wide by 30 high. The only rectangle that we're going to change the arc width on is the third rectangle, R3, and we set independent arc widths and arc values. In other words, the arc width and arc height are not going to match. Arc width is going to only be 15, but arc height is going to be 25. We'll talk about what that means in terms of how it looks visually when we actually run the demo. You may recall that a group is a container that we can put multiple nodes in. So we define ourselves a group right here that we call group, and then we say group.getChildren.addAll to add all of these rectangles that we've made into a group, along with some appropriate texts to label them. The coordinates of the text are specifiable, as you see. So here we say we create a new piece of text at location 1027, and we give it the string R1. If you think about where this is going to be now with respect to the triangle, or the rectangle that it's going to label, it's going to label R1, and R1 was defined to be at 2510 right here. The text that goes with it, the label for it that says R1, is at 1027. So what does that mean now? Well, it means that it's to the left of the edge of the rectangle, because the edge of the rectangle is clearly going to be 25 pixels in, and the text is only 10 pixels in. So something like halfway between the edge of the window and the place where the rectangle is where the text is going to appear in the X dimension. In the Y dimension, well, the rectangle starts at 10 and it is 30 tall or high, 30 high. So it extends from pixel 10 to pixel 40, and roughly the middle of that would be something like pixel 30, and you can see that 27 is around the middle of that rectangle then. So that seems to be an appropriate place for us to put the label R1. I won't go through the same level of detail with the remaining pieces of text, but you'll see that it works in a similar fashion. So we put the label R2 at position 1067, and we put the label R3 at position 10107, and then we put the rectangles in the pane as well. Now, incidentally, we could juggle the order of this up any way we feel like, because we've given explicit coordinates for each of these children, which means the order that they're put into the group is not material. We'll prove that by juggling it up in just a moment. Now, the next little bit of code, the author has a little bit of fun. We're going to go ahead and comment that out for now. We'll come back and play with that. But for now, let's just get rid of it so we can run what we've talked about so far in the demo and see what it looks like. So I'm going to go ahead and run this the way it is right now. And there you have exactly what you were promised. Remember, we filled them differently. So R1, we specifically filled it with white. We didn't specify a fill for R2 or R3 or a stroke, but the default for both is black, so that's why we got black stroke and black fill for both R2 and R3. Notice R3 has rounded corners because we've set an arc width rather than leaving it at the default of 0. Now, maybe we could adjust the arc width to emphasize what's happening with it. Let's change the arc width to a much smaller number. How about 6 perhaps? And let's change the arc height to a much larger number, 60, and let's rerun the demo so you can see what effect that has. So we're going to run it again, and then let's bring both of these up. So this was the original and this is the new, and you can see what's happened now is there's a much wider sweeping curve that brings us down to the side here, but it's very small of a curve as we go to in the X dimension left to right up at the top here. That's because we've made a very small number for arc width but a very large number for arc height now, as opposed to what you saw earlier here. I suppose one last thing we could do is just prove to you that if we set both of those for 0, then in fact we're going to get sharp corners then. So let's run that demo one more time. And we'll bring up all 3 variations for you. And you can see that now we have extremely sharp corners because arc width and arc height have been shrunk all the way down to 0. So that hopefully leaves you with a good impression of how those parameters work now. Also, let's go ahead and juggle up the order that we drop things into this pane, just to make it very clear that the order is in fact immaterial. So how about if we were to, I have to be a little bit careful here, or maybe I really don't. I think, yeah, I guess I could pretty much do whatever we like here. How about if we put R1, R2, maybe R3, and then R2 in that order, and then I'm going to remove them from the other parts of this statement. So I'm going to get that one and that one gone. And let's go ahead and put this guy here at the very end. I'm going to need a comma there. And, well, let's leave the others where they are. I think that'll be enough to prove the point then. Oh, and I've got an extra comma that I don't want here. So let's comment out the, or for that matter, let's just delete the original. And let's go ahead and run it with this other sort of more random order. Okay, so there's our newest run, and here's the, oops, here's the older run. And you can see that it really made no difference at all. So again, the order that we drop things into a group is completely immaterial if we have particular coordinates specified for each of the items, which we do in this case. So let's just remove all of the code related to what we just saw and now focus on the other part of the author's demo. Is a slightly more interesting part, I think, where he had a little bit of fun putting this together probably for you. Okay, so let's take a look at what happens in this for loop. He's going to make a total of 4 rectangles appear, and they're all going to be based on the same coordinates and size. So all of them are going to show at location 150, and they're going to be of height 100 and width 30, or sorry, width of 100 and height of 30. But what we're going to do is we're going to take this rectangle, and when we add it to the group, which we do down here at the bottom of a line, and remember we're in a for loop when we're doing this now, and as we do it, we're going to change the rotation of the particular rectangle that we put in there. So each time we iterate, we add a rectangle that's been rotated to a slightly different orientation to the group that we're building. Now, speaking of which, we need to actually define our group, and I believe I've commented out, so we're still going to need this line of code right here. So how about if I copy that and paste it in down below here? That should make a couple of those errors that you see disappear. There we go. Very good. So let's see how we determine what angle each of our 4 rectangles is going to appear at. Well, as the loop iterates, I goes from 0 to 3, and on each iteration we're going to take I and multiply it by 360 because there's 360 degrees in a whole circle, and we're going to divide that by 8 because there are 8 different locations we could put this rectangle in the way the author's thinking of rotating it around, sort of an eighth of a circle at a time. Now, because of symmetry, of course, when you rotate it 180 degrees, it begins to cover up other instances of itself. So basically 4 images are going to be enough to completely show a full circle. So I guess the other thing is we should talk about what's happening here. We're also going to randomize the stroke color of the particular rectangle. So every time we run it, we're going to get a different color showing up. How does this work? Well, remember that this color object, the way we've got it set up here, accepts three parameters: red, green, and blue. And math.random produces conveniently a double value between 0 and 1. And it just turns out that red, green, and blue parameters here are supposed to be doubles between 0 and 1 as well. So by saying math random here and here and here, we're going to plug in some random value of red, green, and blue, and that will generate some random color for us. We're going to set in all cases the fill color to white. So let's go ahead and run this now and see what happens. And there you have it. 4 different rectangles rotated around in this lovely figure that you see here. The first one would have been painted at rotation 0. That would be this one right here. And then this is the next one, and the last one in this orientation. And we have a number of different colors showing here. If we run it again, perhaps we'll get different colors. If we run it a few times, we'll get different colors every time. So let's have a look at our handiwork here. We can sit back and appreciate and enjoy it. So as I said, I think your author of your text had a little bit of fun preparing some of these demos for us.